Welcome to aminacademy.com. Let us do mathematical formulae for product of vector. First, we'll discuss about component of vector ijk. In three dimensions, the unit vector ijk are used to represent vectors in x, y, and z directions respectively. These vectors are length 1 and always point in the positive direction of their respective axis. For example, I cape. For I cape vector indicates the direction of an object along x-axis, while j cape indicates the direction of an object along the y direction, and k cape indicates of an object along z direction. Look at here. Here in x direction, one unit vector is I cape vector. In y direction, j cape vector, and z direction, k cape vector. It is a representation of the point in a space. Now, here, suppose vector A. Consider this vector A is represented by A1 I plus A2 J plus A3 K. Here A1, A2, A3 are scalars. Vector A is represented like I, J, K are unit vector perpendicular to the along axes. Now, dot or scalar product of two vectors. That means two vectors can be multiplied in scalar form. That means the dot product is also known as the scalar product. That means finally no direction is an algebraic operation that takes two sequences of number of equal length and return a single number. It is a way to multiply two or more vectors and the result is scalar quantity. Look at here. A vector A dot vector B is equal to modulus of vector A and modulus of vector B into cos theta, angle between them. Therefore, angle between them is equal to cos theta equal to AB vector A dot vector B over modulus of vector A into modulus of vector B. Here, for example, vector A equals 2i 3j plus k. Vector B is I minus j plus 3k. Then what is the product of vector A dot vector B? Is the respective scalars are multiplied. That 2 I is 2 into 1 plus j is 3 into minus 1, k is 1 into 3. Look at here, 2 into 1, 1i, 3 into minus 1, 1 into 3, which is equal 2 into 1 is 2, minus 6 plus 3. 3 plus 2 is 6, 3 plus 2 is 5, minus 1 is minus 6 is minus 1. Now we'll continue that the rules. Vector A dot vector B can be written as vector B dot vector A. This is called commutative over dot product, commutative law. Then next, yeah, A vector dot B vector plus vector C, which is equal A vector A, then which is equal vector A dot vector B plus vector A dot vector C. So distributive. Next is vector A dot vector B can be written as A modulus of vector A is A1 B1 plus A2 B2 plus A3 B3, where A, B, C or A1 B1 A2 B2 A3 C3 are coefficients of that A vector A vector B vector C. Now where A vector A can be represented in terms of ijk A1 I plus A2j plus A3 k vector k. Right, and B vector is, let it be B1 I B2j B3 k. Next we'll discuss about cross or vector product of two vectors. The cross product, also known as the vector product, is a binary operation that takes place in three-dimensional oriented Euclidean vector space on two vectors. It is represented by the symbol cross and is denoted as A cross B. That means cross product of two vectors A and B, where A and B are two linearly independent vectors. The result of this cross product is vector that is perpendicular to both A and B and therefore normal to the plane that contains them. Look at here the formula. Vector A cross vector B is modulus of vector A into modulus of vector B sine theta n k. Look at here this result A cross B vector is equal I1 A2 B3 minus A3 B2 plus J A3 B1 minus A1 B3 plus K A1 B2 minus A2 B1. Here A cross B also can be represented by modulus form I J K. Then this is A1 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 B1 C1 A2 B2 C2. A1 A2 A3 B1 B2 B3. Here this is a modulus determinant representation of cross product of the vectors. Next one. Yeah, we know that A vector cross B vector is modulus of A vector, that is A B sine theta and with n cap. where theta equal 0 is lesser than theta and lesser or equal to 5. Now A cross B, which is represented by modulus I j k into A1, A2, A3, B1, B2, B3 is a determinant form. Now this is equivalent to A2 B3 minus B2 A3 B2 A3 of I plus A3 B1 A3 B1 minus B3 A1 B3 plus this is with J vector plus A1 B2 minus A2 B1 with K vector. Now one more result, look at here. A cross B is not exactly equal to B cross A, but it is minus B cross A. That means vector cross product is not commutative. Next one, distribution A vector B vector plus C vector is A vector cross B vector plus A cross into C vector distributive. Now modulus of A vector cross B vector is area of parallelogram. Area parallelogram. Area of parallelogram having sides A and B. Having sides vector A and vector B. Next, dot and cross product of more than two vectors. Suppose consider first dot product. Dot product of three vectors is A vector dot B cross C. This is a dot product of vector ABC, which is represented by determinant form, that is A1, A2, A3, B1, B2, B3, C1, C2, C3, which is further equal A1, B2, C3, A1, B2, C3 plus A2, B3, C1, A2, B3, C1 plus A3, B1, C2, A3, B1, C2 minus A3, B2, C1 minus A3, B2, C1 then minus A2, B1, C3, A2, B1, C3 minus A1, B3, C2, A1, B through C, B3, C2. That means that here this expansion is here like. Next, modulus of A vector dot B cross C vector, that is dot product of three vectors modulus equal volume of parallel pipe. Volume of parallel pipe having sides with sides ABC, with sides A, B, C. Now vector product of three vectors. Next, vector product of three vectors. Here, vector product of three vectors represented by A cross B cross C, polar crosses, which is equal vector B into vector A dot vector C minus vector C and vector A dot vector B. This is a formula for cross product of three vectors. Next, we can represent this like first A cross B into cross C also can represent, which is equal B vector B into vector A dot vector C minus vector A dot B dot C. Here now vector product, scalar product of four vectors. Next is scalar product of four vectors. Look at here, four scalar products, which is equal as A cross B dot this is scalar product of four vectors A, B, C, D in order is equal vector A dot vector C into vector B dot vector D minus vector A dot vector D into vector B dot vector C. Next one, vector A dot vector B. This is a cross product, right? Cross product of four vectors. Here A vector A cross vector B. Here also cross vector C cross vector D. This is a cross product of four vectors in order, which is equal vector C vector A dot B cross D, B cross C, B cross D minus vector D vector D into vector A dot B cross C. This is the first expression. The same can be expressed like vector B. A dot C, C cross D minus vector A, vector B dot C cross D. So far we discussed about vector algebra, some formulas regarding dot and cross product of two vectors as well as three vectors. We have done. Please subscribe our YouTube channel.